Let us understand details related to CTAS or create table as select. CTAS is primarily used to create tables based on query results. Following are some of the use cases for which we typically use CTAS. There might be several other scenarios, but these are some of the common ones. Also, when it comes to CTAS, as a software professional, as long as you have to work with databases at one point or the other, you might have to use it for different purposes, and having knowledge with respect to CTAS is very important. Here are some of the use cases: taking backup of tables for troubleshooting and debugging performance issues, reorganizing the tables for performance tuning, getting query results into a table for data analysis, as well as checking data quality. We cannot specify column names and data types as part of create table clause in CTAS. It will pick the column names from the select clause. It is a good practice to specify meaningful aliases as part of the select clause for derived values. Otherwise, it will pick up some cryptic names, which is not a good practice. Also, it is a good practice to explicitly typecast to the desired data type for derived values. Otherwise, if you use functions to get the derived values, depending upon the return type of the functions, the data types of the columns will be determined. At times, they might not be the ones which we should be using for our tables. And hence, it is a good practice to explicitly typecast to the desired data type for derived values. Let's load the SQL magic here, and also let's create this environment variable called as database_URL. Let us drop this table if it exists, customers_backup. I'm just trying to create table by name customers_backup with all the data from customers. So this is the simplest form of CTAS. You can have any query here. Depending upon the query results, the columns will be added to the table customers_backup in this case. You can run this. If you want to check the structure of customers and customers_backup, I would recommend either to use SQL Workbench or pSQL CLI. I'm using pSQL CLI here. I have already connected to the database. Let me exit using pSQL command with appropriate credentials. I'm able to connect. Let me enter the password here. Now I am in the database. Now I can say /d customers to get the structure of customers. These are the columns we have as part of the customers table. The columns are nothing but customer ID, first name, last name, so on and so forth. These are the data types, and most of the columns are not null, or all the columns are not null. And also table have the primary key. You can see the details with respect to the primary key here. Now, if you want to get the structure of customers backup, you can say /d customers_backup like this, and you should be able to get the structure of customers_backup. You can see that only column names and the data types are copied from customers. The data types are almost same as customers. Some cases you might see some discrepancies, but in most of the cases when you use select *from, it will just pick up the data types from the source table, which is nothing but customers in this case. However, only column names and data types are copied to this new table. Other attributes such as the not null constraints and primary key constraints, or if you have any additional constraints, those will not be copied. Only column names and data types will be copied when we use CTAS. It is very important for you to understand this. Now, this is another example where I am creating a table by name orders_backup. This time, using the 4 columns in orders, I am actually creating the backup table with 7 columns. 3 of the columns, order ID, order customer ID, and order status, are direct copy. Whereas from order date, I am deriving 4 fields: year, month, day of month, and day of year using toChar function. And also you can see that I am typecasting to int because these can be represented as integers. So this is how you should be developing your CTAS queries. You should not just leave the typecasting. If you do not use typecasting, in this case, all these fields will be created as char type. In most of the scenarios, when we actually store the data such as year, month, day of year separately, they will be represented as integers. So keep that in mind. You have to specify the target data types like this, and also make sure that you have meaningful aliases for these derived values. Otherwise, the column names can be cryptic or it might even fail. Let's remove this and let's drop and recreate and see what happens. So in this case, for date of year, it's still created. Now let's see how the column names look like under orders_backup. You can use /d orders_backup like this, and you can see the output. You see the column name is defined as toChar, which is not correct. Now if I remove for another column, let's see what happens. Because there is only one column and it is successful in using toChar, but now there are 2 columns. Let's see how it works. Now it started failing. So the good practice is you should always use aliases for these derived fields, then we will not be having any issues. Okay, now I should be able to create the table without any issues. We can also preview the results. Already we have seen the column names and data types once. Now let's try again. Now you can see that all these fields are of type integers because we have typecasted. Otherwise they will be varchar because the toChar returns varchar or char type. That being said, you can compare this with orders. When it comes to order ID, customer ID and status, the data types are copied to orders_backup. Order date is not copied into this table. Rather, we have copied the derived columns by typecasting. Now, when it comes to CTAS, at times we have to create empty table with only structure of the table. We can specify always false conditions such as 1 equal to 2. 1 is never equal to 2. If you specify 1 equal to 2 as part of where like this, it will just create the table with column names and data types. No data will be copied into the table. Let's drop this table. Let's run this CTAS query with where 1 equal to 2. Now you can see the output as 0 rows affected, which means no data is copied into the table. You can also run this cert count of 1 on order items empty. You can see the count is 0. So this is how you can actually create empty tables without data using where 1 equal to 2 as part of your query using which you want to create the table. Then only table structure will be copied, no data will be copied. Even with respect to table structure, only column names and the data types will be copied. No primary keys or indexes or sequences or constraints will be copied. Keeping databases clean is very important. It is a good practice to clean up any temporary tables created for learning or troubleshooting issues. In this case, all the tables created using CTAS are dropped so that we don't have these tables unnecessarily. If you want, we will create these things again at a later point in time. I just want to make sure that I have the core 6 tables in orders, and hence I'm just dropping these additional tables which are created here. So this is how CTAS is used for different purposes. Make sure you understand the relevance of it and also syntax and semantics of it. Wherever it is required, make sure you are comfortable in using CTAS and create tables using the query results.